All right, in this video, we're discussing section 10-3 on the areas of regular polygons. Okay, in this video, we'll discuss the center, radius, and apithum of a regular polygon, what those are, and also specifically how to find the area of any regular polygon. Okay, by the end of this video, you should be able to find the area of any regular polygon when you're given the side length and or the length of the apithum. Okay, and to find angles created by radii and the apithum. Okay, some vocab that'll come in useful to us. The center is in the very center of the regular polygon, not too difficult. Okay, the radius is the segment that goes from the center to a vertex. Okay, similar to a circle. Okay, the apithum is a brand new word you haven't heard before. Okay, but that goes from the center perpendicular to a side. Okay, and that length will become very, very useful to us as we're finding the areas of regular polygons. Okay, now the way we find the area of a regular polygon, I kind of think of it as an orange slice. If you take an orange slice and you kind of cut it along the peel and you unpeel it, you get some triangles. Okay, it's kind of how I think about taking a regular polygon and cutting it on one side and unpeeling it and getting a bunch of triangles. Now I know that the area of a triangle is 1/2 the base times the height. Okay, and if I think of all of these triangles as one triangle, the base of all of the triangles is the exact same as the perimeter of my regular polygon. Okay, and the height of my triangles is the same length as the apithum. Okay, which is why that length becomes so useful to us. Okay, so the area of a regular polygon is 1/2 the apithum times the perimeter. This is a very important formula for us in this section. Okay, so to find the area of some regular polygons where we're given the apithum and the side length, okay, number one's about a pentagon. Again, it's 1/2 apithum times perimeter. The apithum we're given, it's 24.3 centimeters. Okay, the perimeter we'll get from the side length and how many sides there are. So if each side length is 35.3 centimeters, and if there's 5 sides in a pentagon, then the perimeter will be 35.3 times 5, and we get 176.5 centimeters is the perimeter. Okay, so to find the area of this regular pentagon, it's 1/2 times 24.3 times 176.5, and I get 2,144.475 square centimeters. Okay, similar thing for a decagon, having 10 sides. The apithum is 19. The perimeter is 12.3 times 10 is 123. Okay, so 0.5 times 19 times 123 is 1,168.5 square meters. Okay, now when we're given the apithum and a side length, it's not too difficult. Okay, but what happens if we're only given one of them? Okay, down here I've drawn out a square, and we'll find out that this triangle down here will be very useful to us. Okay, specifically the angles will be useful to us. Angle 4, I know it's a square, and you can look at it and say, well, it's about 90 degrees, and that's true. But in general, we'll take 360, which is the angle all the way around, and divide it by the number of sides. And we get 90 degrees. Okay, angle 5 is half of that. Okay, half of 90 is 45 degrees. And then angle 6, the other angle, will also be 45 degrees. Okay. So, what is the area of this regular hexagon? Okay, again, this triangle will be useful to us. The area is 1/2 the apithum times the perimeter. And I don't know either the apothem or the perimeter. All I know is the side length is 4. Okay. Now I'll start off with the perimeter because I think that's easier. And if each side length is 4 inches and there are 6 sides, then the perimeter must be 4 times 6 or 24 inches. Okay? Now to find the apothem, I will look at this triangle. This length down here is half of the side length. So it must be 2. And this over here is the apothem. And this angle over here is 360 all the way around, divided by the number of those little triangles you see. Okay? And it will always be the number of sides doubled. So here I have 6 sides. If I double 6, I get 12. Okay? So 360 divided by 12 is 30 degrees. So the angle up there is 30 degrees. Okay? Now, usually we would need to use some trigonometry, but since it's 30 degrees, and this is 90, and this is 60, I have a special right triangle, so I'm going to use that. I think that's easier. So if the shorter leg is 2, the apothem will be 2 root 3. Okay? So the area is 1/2 the apothem times the perimeter. And I get 41.57 inches squared. Okay, let's try another one. A regular octagon. Okay, the formula is still 1/2 the apothem times the perimeter. Okay, I'll start off with the perimeter. There are 8 sides in an octagon, and each side is 3 inches. So the perimeter must be 24 inches. Okay, to find the apothem, I will draw in this triangle. Okay, the length down here is half of the side length, so it's 1.5. And this length is the apothem. And this angle in here is going to be 360 divided by the number of side lengths doubled. So I have 8 sides. If I double 8, I get 16. So 360 divided by 16 is 22.5. Okay, that angle in there is 22.5. Okay, so to find the length of the apothem, I'm going to use some trigonometry. Okay, SOHCAHTOA. And I'm going to use the tangent. Okay, because I know the opposite and I want to find the adjacent. So I'll use the tangent. The tangent of 22.5 degrees is equal to the opposite over the adjacent. Okay, so I put over 1 to solve the proportion. Cross multiply. 1.5 is equal to the tangent of 22.5 times the apothem. To solve this, I divide both sides by the tangent of 22.5. Okay, and 1.5 divided by the tangent of 22.5. So A is equal to 3.62, which is the length of the apothem. So I plug that in, and the area is 1/2 the apothem, 3.62, times the perimeter of 24. And I get the area to be 43.46 inches squared. Okay, now I know this is kind of complicated. You got to first find the perimeter, and you got to find that center angle. You got to use some trigonometry to find the apothem, and then you got to plug it in. There's lots of moving pieces, but if you just follow step by step, you should be able to get it. Okay, a slightly different problem where now we're given the apothem of 5, and we need to still find the area. Now we'll the same formula, 1/2 the apothem times the perimeter. This time we're given the apothem. All we have to do is find the perimeter. Okay, again, this triangle right here is useful to us. Okay, This angle up here is still going to be 360 divided by the number of side lengths doubled. So if I have 5 sides, if I double 5, I get 10. And that angle is 36 degrees. And the length I want to find is this. So I'm going to use some trigonometry. What I know is the adjacent, and I want to find the opposite. And so I'm going to use the tangent. Okay. By the way, in these problems, we will always use the tangent. So the tangent of 36 degrees is equal to the opposite, x, over the adjacent, 5. Put this over 1, I cross multiply, x times 1 is x, and the tangent of 36 times 5 is 3.63. Okay, now to find the perimeter using this length, let's try to fill that in there so we can see it, 3.63. Now, if I double that, I'm going to find this length right here, which is a side length. And I can multiply that by the number of sides, because there are 5 sides. So that times 2 times 5 is going to give me 36.33 centimeters. Okay. If you want to just take that length x and multiply by the number of side lengths doubled, that works too. Okay, so the area is 1/2 the apithum, 5, times the perimeter, 36.33. And I get an area of 90.82 centimeters squared. So in this section, we talked about finding the area of regular polygons, what the center, what the radius, what the apithum is, but specifically how to find the area of a regular polygon when you're given the side length and or the length of the apithum.